quick. All right, we're doing control flow in Python. We're at day 4, and the understanding is we want to get more people involved in programming, especially our Gen Zers. Over the last 10 years, I've been seeing a solid reduction in my computer science mentees and interns that are coming in into my mentorship programs, and especially into my interns. That a few years ago, when I was at a couple of different Fortune 500 companies, I used to have rooms full of interns, and this is 10 years ago, and now the numbers have dropped for some reason. I don't understand, because programming is a fantastic outlet for your psychology, and there's a lot of jobs in the US that can be done by programming. Basically, you give instructions to a computer to perform a task that a human being would otherwise take forever to do, right? So let's look at the status for files, right? We're going to go into day 4 right here. Okay, let's jump right in. I think that it's very important for you to learn to program so that you can give computers proper instructions and you can fulfill those roles for companies and get paid in the process of doing that work for them. This is day 4. We have so far covered basic Python setup, interpreter setup, print statements, what booleans are, what data types of strings are, what integers are, what numbers are, what control flows are. All these basics of computer programming in Python are important so that you can write programs. And once you can write programs, you can give the computer instructions. A program is giving computer instructions to do an actual physical task that a human being would take X amount of time to do, right? So 10 people, right, which is 10x, times 100 minutes, right, is 1,000 minutes of time. 10 people, would do in 10 minutes, in 1,000 minutes or whatever. A computer can do that in like a minute, right? So from the processing power, and I'll demonstrate that with like a for loop to you, and like an infinite while loop and stuff and everything in this lecture. And it'll give you an idea of how if you mistype and you misgive your computer instructions, it behaves a certain way too, which is pretty crazy. All right, so let's kind of like just look at this really quick. What this is talking about right here is saying, hey, what is your age? Computer, you're gonna ask. It's gonna ask you for an input, right? And you're gonna go in and you're gonna say, hey, my age is 12 years old. Now, what does this lowercase I mean? The lecture that we did yesterday had that explanation in it. It's a less than sign, and what its output is that it's true. So if A and B are 10 and 20, is A greater than B? No, A is 10 and B is 20, so A is less than 20. And if you say that it's greater than 20, the output should say false, right? And that's what this is. This is what we covered yesterday. You can see it on the YouTube channel, you can see it on the Twitch stream. LinkedIn has just started today, and yesterday was a little bit of a mess with the streams. So. But this is a live programming session. Anyone can join, comment, talk to me. We can discuss, etc. Anyway, you put in 12, it says you're a child. You run again, you put in 15, it says you're a teenager, right? Because the second statement got activated. The elif statement got activated. When you put in, when you created the age object, right? So if you type in print age, right in there, right? So after the code runs on line 5, it's going to go to line, after a 5, it's going to go to line 6, right? So if you run it again and you hit 15, it'll print out, it'll say that you printed age 15 and therefore you were a teenager. It printed out this, that you were a teenager, because that's where you fell, right? If you fall into 25, for example, or 40, right, it says you're an adult, because it skips over this code and it skips over this code. It says if age is less than 13, false. If age is less than 20, false. So therefore the age is greater than 20, obviously. It's not 0 to 20 or any number minus, right? So you can put in like minus 100 and it says you're a child, because it's less than 13, right? Minus 1, minus 2, minus 5, minus 1,000, minus whatever. I mean, obviously it's not applicable, right? But if you put in 100, it'll say you're an adult, because it's over 20, right? If it's under 20 but over 13, like 14, it'll say that. Now if you put in 20, because it's greater than, right, it'll say you're an adult. Now if I change this to a greater than equal to, so if it says, I wonder if it's, yeah, it has to be after, like that. So if you put in 20 this time, it'll say you're a teenager, because I changed the condition, right? So you change the condition here. That's a conditional statement, right? Let's look at for loops. So we have ages, right? And we're going to say, hey, print out 12, 15, blah, 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 for item in ages. For age in ages. And why do you have a squiggly? Because it doesn't know, the computer doesn't know what item is anymore, because you changed the variable to age. Not ages, age. Age. Now if you put age underscore here, it doesn't know what it is. Again, you can change it over here to that, right? And now what's going to happen, it's going to print everything out on the console again. So hey, what's in this list? This data type is a list. Now how do I know it's a list? You can do print, in the bracket you can say type, and then you can go ages. So you can say, hey, what is the print type of ages, right? What will it print out? List, right? It printed out this part right here, saying that it is a class list. That means the object type ages is a list. What class is the object type? So what class is the object type? List. It's a class list, right? And then it goes on ahead and then it prints everything. Now, if you comment this, age is the person item, right? This gives you a hard-coded string because it's just inside quotations. Now, what is a string? String was covered in day 1. Print hello world. Hello world. Number. Print type is a float. It's an integer class float. And then it puts it into f string and it prints .2f, which is 2 decimal places outside, right? So 651.561.65, which is a 2 float. It's a float. It's a type float, right? It's not an integer. If you don't give it well, if you typecast it as an integer, then it becomes an integer, right? So let's typecast it into an int. So hey, print this as an int, and you will see that it got passed out as an integer. So we took the same number up top, which is number, and we changed it into a different data type, which is the integer type. right? So we can go int1 is equal to this. And then we can just type in print int1. What happened? Where did it go? No, it quit. It quit everything. Come on, where was it? Oh. Right. Anyways, sorry about the abrupt breakdown stuff. I don't know what happened, but I'm sorry about that. Anyways, we're covering ages, right? It printed everything out in our ages for us. We were doing this, right? So it printed out all the item because it's hard coded as a string. If we change this to a f string, then it actually prints out the value, right? 20, 25. We want this value printed out, right? We want this value printed out on our computer. There we go. Age of person, blah, 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 because we have a loop. Now, what is a for loop? Right, a while loop now. That was a for loop. So print while loop count to 2, right? So print what the count is. And the count is less than 3, then it'll be an infinite loop. We'll see why this is going to be an infinite loop in a second, right? So it printed out count number. What is the count? Count is 2 because we set the value to 2, right? So let's So I printed out the count to 2, as we can see, right? Now, what's going to happen is we're going to go ahead and have an infinite loop running, right? Why are we going to have infinite loops? Because we're getting a condition saying, hey, while the count is less than 3, because the count is 2. If the count was 3, it wouldn't even execute this, right? Because the count is 3, so it won't print anything. It doesn't know what to do, right? It's refused it. No gonna. Let's go to our bash. Better still, let's just run it, right? So this loop is not executing while the count is 3, so it's not executing, right? So if we change the count to 1, for example, right, it'll just start running for infinitely, as you can see that, right? And that's a problem for us, right? So we don't want that situation right there. Control C, right? So we don't want that. Right. Now let's look at this piece of code right here. So if we set our count to 5, we print out 5. Now while count is greater than 0, which it is, it's 5, right? Then what we do is we count plus equals to 1, which is something that again we covered in yesterday's lecture. If you look at plus equal to 2, what this does is it takes 5 and then it adds 2 to it, which gives us a total of 7, right? So any number plus equal to, when you do that, it's an incrementation. So what's happening is from 5 it's going to 6. It's going to print out 6. Then it's going to loop again, because then it's going to say, is 6 greater than 0? It is. 6 is greater than 0. So then it'll print out this stuff again, right? So you will see an infinite loop again. You see the number is increasing, right? So that's really what's going on here, is that it's just going bananas, right? And you can quit it by giving it a control C or whatever. Now, if you change this to a decrement, think about what the logic is going to do. It's going to say, hey, the number is 5. Is the number less than 5? Yes, so print out 5. It's going to say, hey, minus 1 from it, which is 4. It's going to say print out 4, right? And then it's going to do that again. That's what it does. And it says that it's because incrementation has reached 5, it's going to stop, right? And you can give this as you have to put in the letter F for an F string, right? And you can put in the actual count. Reached count, right? So it'll print out 5. The count has reached 0 because a decrementation has happened, right? Right. Okay. Let's go into another loop. This is again an infinite loop. It's going infinite because, think about it, count is equal to 3. So while the count is greater than 0, which it is, it's 3. So the condition is true on line 45, right? And because the condition is true on line 45, right, it's going to keep running, right? It's going to keep hitting the count, and it's going to keep adding 1 to the count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 300,000, 600,000, 800,000. Human beings can't deal with numbers this fast, right? We can't put out numbers this. It's already at 600,000. It's a computer, right? So the instructions you give the computer are paramount in its behavior. It's behaving like this because you've given it instructions in Python to do something, Imagine you had to read an Excel sheet that was 1,000,000 lines long. It would read it immediately this fast and put it somewhere else for you and check if there were any spelling mistakes in it. You can check for stuff like that, you know, and you can automate stuff. Like they're phenomenal now, provided you give them the right instructions, right? This should only print 2 things out. We only wanted to print 2 things out. It's printed 2 million, right? So what we do is we just change the sign here. And what are we doing? We've changed it from incrementation to decrementation. So incrementation is increase. We said, hey, the count is 3. As long as it's 3, print. If it's greater than 0, print something. But hey, then take the count and minus 1 from it. So now the count becomes 2. Print it out, and then what's the count? Is the count greater than 0? Yes, so print the loop again. Oh man, take 2, subtract 1. If it's 1, it's greater than 0, yes, print it again. And then 1 minus 1 is 0. Or is it greater than 0 or no? So then stop printing, right? Print done. Because what it does is, while it breaks, the loop breaks, right? So 3, 2, 1. You see that at the bottom, right? And that's what we wanted. Here's the nesting example. Nested for loops. The outer loop and then inner loop. So you take a for loop and then you take another for loop inside it. So what you do is you build a multiplication table, right? 1 through 4, range 1 through 4. What that means is range 1 through 4 means 1, 2, 3, but not 4. And it started at 1. So if you started at -1, right? It goes -1, 1, 2, 3, 4. That's 5. So the outer loop is going to run 5 times. When it runs 5 times the first time outside, inside it goes 1 through 4, which is 1, 2, 3. Not 4 times, right? It's 5 and 3, so it's going to run once, then 3 times, then twice, and then 3 times, then 3 times, and then 3 times, 4, 3 times, and then 5, 3 times, and then finish, right? So you're going to see an output, which is a lot more big, right? You're going to see 1, 2, 3, 5 blocks, you know, by changing that. Instead of 3 blocks. Now you're going to see 3 blocks again. Right? 3 blocks. Right? And that's the same thing over here that I've demonstrated. Again. What you do is you do for x in range, 2 to 4, print x. And what it's going to do is it's going to print 2 and 3, not 4, just 2 and 3, right? 2 and 3. Right, okay. Now what you do is you can take the x value and then you're going to do y. So our loop is going to run 2 times and the inner loop is going to run 3 times, x and y, right? Because the x was valued at 2 and 3 and y was valued at 1, 2, 3, which is 3 times, right? So 2 is going to get multiplied by 1, 2, and 3. So 2 into 1 is 2, 2 into 3 is 6, 3 into 2 is 9, right? So the first table is going to have that value, 2, 6, and 9. And you should see that right there, 2, 4, and 9. 2 into 2 is 4. Right? And then in the next round is 3 into 2 over here. So it's 3 into 2 over here, and it's 2 into 2 over here, and here's the x value itself, right? So x into 1 is 2, and then 3 into 1 is 3, or whatever, right? So that's what you get over here with the multiplication. This is nested for loops. Nested for loops, okay. Arithmetic operators. Why? Because we want to understand the modulus. What the modulus does is the remainder, right? We covered the modulus earlier, yesterday as well. If you look in our code, we went over here and we understood the modulus. This is where the arithmetic operators come from. A and B is 10 and 20. If you actually do it the proper deletion, the actual division, right, you get a remainder. 20 divided by 10 is 2. 10 divided by 20 is 0.5, right? So that's what you get. 0.5 and 10, right? 10 modulus 20 and is the remainder is 10. 10, right? 10 divided by 20 is 10 ones are 10, right? And the remainder is 10, right? And that's what that is over there. Why is that important, right? In your statements, if you give a nested if statement, you can add this kind of logic in your programs where you can just take numbers and divide them by a modulus and get a remainder. Now, if the remainder is 0, it's equal to 0, the statement is true, right? So it's true. Right. So let's try this over here. Python, right? So number is 1 modulus two is 1, right? So is 1 equal to 0? False. So it's an odd number. It'll print out that the number is odd for 1. Now same thing with 2. 2 modulus 2 is 0, right? So is 0 equal to 0? True. So it'll run, hey, 0 is even. It'll print this, right? So let's exit our console, our Python console, right? So we go Python, and then file name is day 4. Let's save it. Make sure it's saved. There you go. Odd, even, whatever, right? Prints all that out for you. Okay, great. I'll push the code, and you guys will have access to it. You can clone the repositories locally. If you're not sure on how to do that, we covered version control, Git pushing code up to the repo, managing it, all that stuff. We're on day 4. We're going to go to day 30 to cover the basics. Then we're going to go into intermediate AI machine learning models after we cover algorithms. So we're going to intermediate, then we're going to algorithms, and then maybe we can look at some maybe we'll look at like an Edmund Karp algorithm for network optimization or something, because that's what I'm covering right now in school, which I find is very interesting. It has a lot of applications for like blockchain and stuff, but we'll get into that later. And if we could also pivot into Java and C++ as well. So if that interest is there, let me know, and I will talk to you guys tomorrow online. We'll do another session. We'll be at day 5. All right, thanks. So again, Python installation, comments, strings, integers, floats, booleans are covered. Operators and data types, which we already looked at, like all these are operators, different kinds of operators, computational operators, assignment operators, arithmetic operators, computational operators, logical operators, true, false, and then operator precedence, which is PEMDAS or BODMAS or whatever you guys are used to, right? In India, they call it BODMAS. In the US, they call it PEMDAS, which is something in school that you guys probably remember in algebra class, talking about precedence. So we covered that in our operator section, and then we did control flow today, which is everything from if statements, for conditional statements. We did for loops, we did while loops, infinite loops, incrementation, decrementation. We did nested for loops and multiplication tables, and we did modulus, and we did a modulus operated control flow as well.